So now we have the arm, the physical arm built. We don't have the pincher on yet. We don't have like the support stuff really on, but we have the basic arm built and everything screwed on. And now we just, I don't know what we need to do. I don't know what we're doing next. I think we need to actually attach the arm to the chassis, attach the pincher to the arm when we have it done. But yeah, right now we have a good start with making the arm, and the arm is done, and that's mostly done, I think, so that's good.
Hello, I'm James Lincoln. I'm a sponsorship captain in the New Prague High School Robotics Team. I am also a build team member, and here I will be demonstrating our arm mechanism, which we just got assembled in the last 2 hours. So we thought we would do like an arm and wrist kind of system where the wrist would be down here and the arm mechanism would be up here. We do not currently have the motor attached that will be moving the arm. And then we'll have a chassis down here, which we don't have it attached yet. But so the basic idea is we're going to have a wrist attached with 2 motors to the bottom here, and we're going to have this sitting somewhere around the bottom of the chassis, either sitting or kind of hovering over it. And then whenever we have a power cube come in, and if you watched, I believe it's Time Bits episode 2 or 3, we have a demonstration of the power cube getting sucked in. So this will hold it there. Then the wrist will move up and kind of sit right there. And since I don't have an assistant, at that point, the arm will move the wrist all the way up, sit somewhere around here, and then we will move up like this. And right about here we will be about 16 inches extruded, which is our max, and that's why we have to put the wrist up. And then we will go to the scale, which we would have to go to about here, the scale, or the switch, and we would have to drop the box into the switch to get points, or if we had to go to the scale, should be able to reach the scale, which is about here or about somewhere around here. Then we'll be able to drop it as soon as the wrist goes down and releases. So that's the basics idea of our arm design and a little bit of a demonstration.
So we've been working on the lead screw assembly. So essentially it's a piece of 3x3 tubing with some 1/4-inch plates. And what's going to happen is we have these lead screws that we got acquired through First Choice. And when you spin the lead screw, it advances the nut up the rod. So we're going to turn the rotational power of a sim into the linear force to lift the arm on the robot. So essentially, this is going to be all hidden inside of here. And we're going to have a giant motor here, a sim motor to spin it. And we're also getting parts 3D printed as guide bearings for the top. And then this is going to mount inside our robot and pivot on a shaft. And it's going to extend to lift up the arm.
Hello, back here to talk about what the team's been up to. We've been really busy this past week. We're finally getting the robot assembled. You can see we actually have something here now, not just the chassis, but yeah, we're a little bit slower this year. We are being really thorough on making sure the math worked out and getting all the parts ordered. We spent a good long while figuring out this arm here, because when we want to bring this arm up, we had to measure out the certain angle so it doesn't extend outside of the limits, otherwise the robot would be illegal. So there's a bunch of measurements using angles and trigonometry to solve for what length this could be, and then we had to do a bunch of equations to figure out how much force the linear actuators that are going to be situated around here have to push up to lift this arm off the ground. Because if you remember, we're planning to lift a box 7 feet in the air at most, so it has to be pretty strong to lift this entire arm up there. Anyways, yeah, that's why it took us so long to get this far. We had a bunch of calculations depending about how far this arm would come down. For instance, that's angle 1, so that the arm would come down this far and still be able to grab the box out here. And then keeping in mind that this arm isn't going to be able to shift lengths, it's going to come all the way up here, but it's not allowed to exceed a certain limit. So we had to figure out a good measurement for here to here that would still work for both of those limitations. And because of that, we had to do a bunch of calculations in trigonometry going from, say, resting position here up to this angle, which we'll say is 0 degrees, and then from this angle up to 7 feet high, another one like that. Not the most complicated trigonometry, but then when we start throwing in how far the linear actuators from somewhere around here have to push up, the force gets pretty difficult to calculate. And then it's all based on a lever system, so the stuff up here towards the end of the arm is going to weigh more because it's on the end of this whole line. It's kind of like lifting something on a, if you're lifting a plank of wood, it feels a lot harder than if you hold it at the end of it than in the middle. That's just a lever system. So yeah, that whole force calculation took us a lot of time to figure out, and then came the issue of trying to calculate the lead screw strength, which is a long equation, can't go into detail because too many variables, but had to do with a bunch of tension and torque forces on it to see how much it could withstand and whether or not it was even possible to lift this arm, which turns out it can. Awesome.
Long story short, right now, we're not really going to go really in depth. Basically, our job on strategy is to understand everything about the field, everything about what's on the field, other teams, what they're doing. We need to know our robot to the best of our ability. We need to know what it's capable of, how fast, and everything. So as soon as the robot is done, it's going to be our job to test to see what our robot can do, and basically, like I said before, how fast it can do it. We need to know our robot inside and out. We need to know how everything works on the field. We need to know how everything looks. We need to know how everything operates. A good example is knowing how the dispensaries work. Just going real quick about these, you literally insert it. I don't know where the images are. If I keep scrolling, I'll eventually find them. You put the cube in, you grab both of these sides and push, and it does everything when it comes to dispensing the cube on the field as you need to. So yeah. Nope. Keep
Is
moving.
strategy also going to be a prerequisite for human players?
Yes.
Okay, that's what I'm
I just want to get on this stuff figured out.
here for scouting.
What else do you have to do to be a human driver or drive?
To drive, basically, to be a driver, you have to be on strategy, and every single day, once the robot's done, we're going to practice driving everyone. And once,
Okay.
like, what?
No, we're going to talk about that after.
We're going to practice driving, and then, yeah, whoever is the best at driving will probably be designated head driver, and et cetera, et cetera.
We
And
don't
it can
get
either be
designated
who's
driver
objectively the
after any
best.
alcohol involved.
Huh? What? It can either be objectively who's the best, or who the team, or team votes should be the head driver. And then if one of you were to meet a freak accident, we would have, of course, replacements. And this also involves, like Lockhart had said, we're going to other pits, talking to those team members, and a good idea that what other teams have done is take laminated sheets of the field, slide them on like this, other way get a more cleaner image of it, and basically do along the lines of, what can your robot do during autonomous? If all of them can pass, you tell them they can pass, and then tell them what they would do. And we standardize certain things and talking points. So yeah, that's really it.
Yeah.
If you're, what?
I think we should hold off on going in depth until.
Oh yeah, that's what I was just about to wrap. I was just about to say, if you're interested in it, talk to me later. I'll put your name on the list. If you don't really care, that's fine.
And we'll probably end up putting more people on the list anyways.
Well, yeah, if we need it. If we don't have enough, then we'll add people.
Yeah, there will be a draft if there are enough people. So.
All right. So you go. If you're working on something else, go ahead and do that.